Example 1. If we roll a standard 6-sided die, describe the sample space and some simple events. So first of all, the sample space is the set of all possible simple events. So we can write this as a set of numbers inside these curly braces. So what are all of these simple events? Well, with one die, I can roll a 1, I can roll a 2, I can roll a 3, a 4, a 5, or a 6. So these are all the possible outcomes, which means that this is our sample space. So here are some examples of some simple events. We roll a 1, that's a simple event. We roll a 5, that's a simple event. Now, something different than a simple event would be compound events. So here are some examples of compound events. It's kind of like the opposite of a simple event. We roll a number bigger than 4. So there are more than one number bigger than 4 on this die. And so it's not just a simple event anymore, it's now a compound event. Another example of a compound event would be we roll an even number. And just to help us with the language, the singular form of this object is die, and the plural form is dice. So we can say I have 1 die or I have 2 dice, but we don't say I have 1 dice because that doesn't make sense. So this brings us to the concept of basic probability. So given that all outcomes are equally likely, we can compute the probability of an event E using this formula. This notation over here is the function notation that you often see in algebra, where the P is like the name of the function, and inside the parentheses next to P is what is inside of the function. So these are not multiplication. This is not multiplication between the P and the E. This is probability of E happening. And so we calculate that by taking the number of outcomes corresponding to the event E and dividing it by the total number of equally likely outcomes. Here's example 2. If we roll a 6-sided die, we are asked to calculate A, the probability of rolling a 1, or B, probability of rolling a number bigger than 4. So remember that the sample space is the set of all of the outcomes. We can roll a 1, we can roll a 2, we can roll a 3, 4, 5, or 6. That's the sample space. So the answer to part A is that there is one outcome corresponding to rolling a 1. And so the probability would be 1 out of 6, or 1/6. The answer for part B is that there are 2 outcomes bigger than 4. That would be 5 and 6. So the probability is 2 out of 6, or 2/6, which can simplify to 1/3. So you'll notice that probabilities are essentially fractions. So they can also be reduced just like fractions can be reduced to lower terms. Here's example 3. Let's say you have a bag with 20 cherries, 14 are sweet and 6 are sour. If you pick a cherry at random, what is the probability that it will be sweet? So the way we figure this out is there are 20 possible cherries that could be picked. So the number of possible outcomes would be 20. And of these 20 possible outcomes, 14 are favorable, meaning they are sweet. So the probability that the cherry will be sweet would be 14 out of 20, which can simplify to 7 out of 10. So there's one potential complication to this example, however. It must be assumed that the probability of picking any of the cherries is the same as the probability of picking any other. So this wouldn't be true if, let's imagine that the sweet cherries are smaller than the sour ones. So the sour cherries would come to hand more readily when you sampled from the bag. Let's keep in mind also that when we assess probabilities in terms of the ratio of favorable to all potential cases, we rely heavily on the assumption of equal probability for all outcomes. So in this case, we would be assuming that all of the cherries are the same size so that our hand doesn't tend to favor picking one over the other. Now is your chance to pause the video and try this example for yourself. So go ahead and pause it, and once you're done, hit play again and see if you get the right answer. So this example says, at some random moment, you look at your clock and note the minutes reading. A asks, what is the probability the minutes reading is 15? B asks, what is the probability the minutes reading is 15 or less? So here is the answer. There are 60 possible readings. We go from 00 to 59 on a clock. So to answer part A, the probability is 1 out of 60. There is only one time where the minutes reading is 15. Part B, the probability is 16 out of 60. So if we count 00 through 15, that's 16 different minutes readings. That would be 15 or less.